Welcome to section 3.2. So 3.2, we're going to split up into 4 days to make sure we get really good at all the various things that are happening in this section. So today we're diving into least squares regression lines, okay? And again, this is something that you saw back in Problem Stats. I'm hoping you saw it in Algebra 2. In fact, I know you saw it in Algebra 2. So again, this is hopefully quite a bit of review for you along the way, okay? So suppose y is a response variable, x is explanatory, the regression line relating y to x has this form, okay? Now, students sometimes get into this panic because you're used to seeing something like y equals mx plus b, but again, you can see the same thing. Just here, this, the number by itself, is your y-intercept. That b is going to be your slope. So again, I know it kind of says kids in a panic that it looks a little bit different, but it's fine, okay? Don't panic too much about what it looks like because you know forms of lines. You know that a is your y-intercept, b is going to be your slope. It just looks a little bit different. And it's written backwards, but again, commutative property says that that doesn't matter, right? So how can we read this? Well, for starters, that y hat is the predicted value of y, okay, the predicted value of the response variable. Then just like I said, b is going to be your slope, and your slope is the amount by which y is predicted to change when x increases by 1 unit. That interpretation is going to be utterly important, so I would put a star by that. Okay, that's going to be really, really critical as we work through the section, that interpretive piece. The a is your y-intercept, which is the predicted value of y when x equals 0. Okay, now there's two ways we can make a line of best fit. Okay, the first way, the way that you already know, is using your calculator. Okay, so let's really quickly go back. Let's review the skill of how can I do this when I'm given a list of data. Well, list of data, hopefully you're thinking, I can use my calculator for that. So we need to go to your calculator, go to Stat, Edit. Now I already have some information here, so I'm just going to clear that out. That was from my last video. Now I'm going to type in all of the temperatures as x's. So 1, 10, 15, 20, 25, 30. All the y values, or oxygen concentrations, as y's. So 14, 11.5, 10, 9, 8, 7.5. Okay? So here we have all of our data in, okay? And again, this entire chapter is dealing with x's and y's. So again, we're getting that habit of making two separate lists. So now we need to figure out how do we make that linear regression. So I'm going to go to Stat, over to Calculate, and now here you'll notice there's two linear regressions, okay? Quite honestly, I don't care which one you use, okay? Whichever one you use is your personal choice. You just have to know how to write it, okay? So for example, if you're going with number 4, if you hit linear regression for number 4, x's are in list 1, y's in list 2. Here is your information, okay? And here what is giving you, this is what's with your x, so that is going to be your slope. This is giving you this, which is by itself. So that is your y-intercept, okay? So let's jot that down on here now. So y hat equals negative 0.23x, then I think plus 13.85. Okay, so know how to write your equation, okay, and it always kind of gives you the format that you're looking for. And then label your variables. So that means y hat is predicted oxygen concentration. And x is going to be temperature. All right, so now that we know how to make those equations, let's dive into the interpretive piece. Interpret the slope of the regression line. So here, the slope is always a value with the x. So here, interpret the slope. Well, remember, interpreting slope means when x increases by 1. So if the temperature increases by 1 degree Celsius, the oxygen concentration decreases by that 0.23. Okay? So, oh, I'm sorry. I never commanded it. Oh, there we go. Never put in that command. So for every increase in 1 degree Celsius, the oxygen concentration is predicted to decrease by 0.23 ppms. Okay, so you're using the slope in there. Now the decrease is coming from the fact that the slope is negative, right? So that's why I'm saying that it decreases, okay? But again, when x increases by 1, the slope tells you how y is predicted to change. Y-intercept. Well, the y-intercept is that number by itself, okay? And what the y-intercept is it is the predicted value when x is 0. So what is that saying? Well, that's telling me at 0 degrees Celsius, it's predicted, the oxygen concentration is predicted to be that 13.85. Or 13.9, sorry. I rounded it in there. Okay, so knowing those two things is going to be really, really important as we work through the rest of this section, okay? And that's why how do you star it up top? All right, so now let's move on to another example, okay? So once again, we need to take a moment and we need to plug these things into the calculator. Oh, and I'm going to erase all of that. All right, so to plug into the calculator, I need to go back into my lists. I'm going to clear them out. And now let's enter my data. So 85, 71, 84, 66, 77, 75, 68, 91. Scoot over. My Y value is 200, 160, 170, 120, 180, oh, I missed a 120. I'm sorry. There should be another 120 in there, then 180, then 100, then 230. All right, now I'm going to show you something really quickly, which is just a quick fix for something we're going to need later. So I want you to go second 0 to get yourself into the catalog, okay? If you hit this button right here, it'll take you directly to the D's. And now I want you to hit diagnostic on and enter. What that's going to do is now when I do my linear regression, now it's going to calculate R for me, okay? Now, if you notice before, mine didn't do that, but now that I've hit that, Now it's going to. And again, to get to R, or to get to the regression, we're going to go to Stat, Calculate. Now, just to show you the difference, now, this time I'm going to do the other linear regression and show you how it looks, okay? So here is my linear regression this time, okay? Notice now R is showing. Now, when it wants me to write my regression line, y hat equals A. This time, A is the number by itself, okay? You always look right here to show you the structure of the line that you're making. Here, B is the number with X. So notice, remember I showed you that the AP Stats book had this written flipped because they use this 8th version of the linear regression, okay? But if you just follow what this equation is telling you right up here, then you're always going to get it right anyway, okay? So always just look, note which one you're using, and then use whatever you're comfortable with, okay? I'm not going to tell you which one to use. I just want to make sure that you're aware of the two different versions of them. So let's jot this down. So y equals negative 163.41 plus 4.19x. And again, it's reminding me to go and label my variables. So here y is going to be the predicted ice cream sales. And x is my temperature. So my explanatory variable is x. I'm using the temperature to describe the response variable of my ice cream sales. Oh, sorry, I forgot my x there. Interpret the slope. Slope is always the number with x, okay? Always. So if I'm going to predict this, remember slope says for every increase of 1x, so when the temperature increases by 1, it tells me how y is changing. So so my ice cream sales are increasing by 4.19, $4.19. So for every increase in temperature, or in 1 degree, ice cream sales are predicted to increase by 4.19. And what about the y-intercept? Y-intercept is where x is 0. So it's predicting that when the temperature, that should be 0, not 9. I'm sorry. That should be a 0. The temperature is 0 degrees Fahrenheit. Temperature sales is predicted to be negative $163.41. That should strike you as a little weird, right? Is that possible? So here, what I want you to note is this is not appropriate because you can't have negative sales, okay? And this happens due to extrapolation, okay? So what is extrapolation? Well, extrapolation is the use of a regression line for a prediction far outside the interval of values of the explanatory variable. So what does that mean? Well, look at all of my values for x. They are nowhere near 0. So it makes very little sense for me to use the y-intercept because I was not getting any data around x being 0. That's not going to be an accurate result. Okay, so that's something just to make sure you're aware of. That term does come up, extrapolation. So again, you should not be making predictions far beyond the data that you collected. Okay, they have to be relatively close. Now I can make predictions. Okay, so based on my line, I can predict the temperature or predict ice cream sales when the temperature is 80. So for that, all I have to do is plug in 80 for x because the temperature is an x value. So all I have to do, plug that in. So negative 163.41 plus 419 times 80. My predicted sales are about $171.79 when the temperature is 80 degrees. And that is a much more reasonable value because I'm not extrapolating my information to get that value. And R, so the correlation coefficient. Now here, this is a cool thing of we actually got to see it on the calculator. R was already given to us. The calculator makes it for us. That's why we did that diagnostic on piece, okay? So my R is about 0.84. And what can I say based on that 0.84? Well, I can say that it means that there's a strong positive linear association between temperature and ice cream sales. And why can I say that it's linear? Well, I showed you the scatter plot up here, okay? So that's how I could add that piece in because I'm looking at the scatter plot. So R gives you two things. It gives you direction and it gives you strength of the relationship, okay? And the linear piece I added in because I was looking at the scatter plot. All right, so once again, thank you so much for joining me for these notes. If you have any questions, please feel free to ask.